We have 1.2 carat diamond, which we are asked to determine the number of moles. So we got to determine the mass of diamond that we have at first. So 1.2 multiplied by 200. But when we want to determine the number of moles of carbon atoms, we got to ensure that the mass that we're dealing with is measured in terms of grams, but we are dealing with milligrams here. So we got to divide this expression by 1000 to change the mass of carbon we have into grams. After that, if you recall the formula of moles, mass and molar mass, you will know that to determine the number of moles, we need to divide the mass by the molar mass. So moles equals to mass over molar mass, which is numerically the same. Molar mass is numerically the same as the relative molecular mass. Okay, so we got to divide this whole expression here by 12. After that, you will get this expression as 1.2 times 200 over 1000 times 12 grams, so which gives us answer D. In this question, we are asked to determine the overall percentage yield for a 25 steps reaction. So to make things easier for you to understand, you can imagine it to be like the scheme which I drawn up on the screen. So you can imagine that I have different stages, stages 1 all the way to stages 26. And when I get from one stage to the other stage, I'm doing a one-step reaction. So since we have 26 stages, to get from 1 to 26, we need 25 steps. And for us to do so, each step like this, we only get a 90% yield, right? So which is 0.9. So as you can see, as we progress from one stage to the other stage, we will have less and less of the product that we want to manufacture. So if we multiply 0.9 for 25 times, so which is 0.9 to the power of 25, multiply it 25 times, we will get a number of around 0.072, which is 7.2%. Yep, and that sums up this question over here. Okay, in this question, we are asked to determine the value of X, which is the number of molecules of water attached to this hydrated salt of barium chloride. We know that this barium chloride salt, hydrated barium chloride salt, is going to react with excess sulfuric acid, which will give you barium sulfate. Now, if you realize this very quickly, you will realize that all the barium here must come from the barium here, because there's no other way, there are no other chemicals that are providing barium in this equation. So since we know this fact, we can set up an equation to determine the value of X this way. Okay, so we know the number of moles of barium sulfate will be equal to the number of moles of barium chloride dot XH2O, because the source of barium here must be from here. So no choice, they got to be equal. The number of moles got to be equal. So the number of moles of barium sulfate is 1.864 over the molar mass of barium sulfate, which is 233.4. This will be equals to the number of moles of barium chloride dot XH2O, which is 1.936 over barium chloride 208.2 plus I have some water here. Remember, I have some water here, so it's 18. I'm not sure of X, so I put an X here. And these two values over here, this value and this value, okay, they must be equal, because I say again, all the barium in the reaction must come from the barium in the barium chloride salt. Now this is a very simple equation to solve then. After you solve for x, you should get an x value of 2, which gives you option B. We have an iron bar weighing 664 grams. So after 1/8 of the iron turned to rust, which is Fe2O3, we are asked to determine the final mass of iron bar left and the mass of rust that was formed. So we have originally 664 grams over here. So if exactly 1/8 reacted, we would have 83 grams of iron that would have reacted. After that, we take 664 minus 83, we are left with 581 gram of iron. So over here I have an unbalanced equation of iron reacting with oxygen to give you Fe2O3, which is rust. To balance it, I need a 2 here, and I need a 3/2 here. Okay, so over here I have 83 grams, which is from the previous calculation. So 83 grams, I would have to convert it to number of moles. So 83 over 55.8 moles. And I have a 2:1 ratio over here. So the number of moles of Fe2O3 that will be formed is 83 over 55.8. I will multiply it by half, since I have a 2:1 ratio over here. Yeah, so I will have this much moles. To change the number of moles over here to grams, I would have to multiply the number of moles of Fe2O3 by 159.7. Okay, so I will have to multiply it by 159.7, and I will get the mass of Fe2O3 form. In this case, I will get a mass of 118 gram. Okay, Fe2O3. Yeah, so since we are asked to find the combined mass of iron and rust at the end, so we got to add up this number and this number. We add them up and we get a value of 699 grams, which is option B. In this question, we have a 100 gram mixture of NaBr and Na2SO4, and it's also given to you that it contains 30% sodium by mass. So very simply, we can let the mass of NaBr that we need to find be an unknown x gram. So if it's x gram over here, we will also know that we will have 100 minus x grams of Na2SO4. And also from a simple calculation, we will also know that we have 30 grams of sodium in the mixture. Next, we need to determine the mass fraction of sodium in the two compounds. Okay, over here. We know that the molar mass of NaBr is 102.9, out of which 23 is the contribution by sodium over here. Similarly, we do it for sodium sulfate. Total molar mass of sodium sulfate 142. Out of which 46 is a contribution by sodium. Since we have the mass fraction and we know the mass of NaBr that we have in the mixture, we can use this fraction over here, multiply it by x, and we have this fraction over here, multiply it by 100 minus x. This will give us two values. So the two values over here, this value and this value, is going to be the mass of sodium in the mixture contributed by sodium bromide and sodium sulfate respectively. And if we were to add these two numbers together, we should get the total mass of sodium in the mixture, which we have already, okay, which is 30 grams over here. So what you have to do now is to set up an equation an expression which adds up this value over here and this value over here. Okay, you add them both together, there's an addition, and you will get 30 grams. Since there is only one unknown in the equation, you can solve for x to be 21 grams. And that's it for this question.